A new study has just been released that may point to something truly groundbreaking, that we might not be alone in the universe. A group of researchers has discovered compelling evidence suggesting that at least 7 stars could potentially be surrounded by highly advanced alien megastructures, known as Dyson Spheres. These structures would be capable of harnessing the full energy output of their stars, an idea that seems like pure science fiction, until now. Imagine, for a moment, a future where humanity develops the technology to build a superstructure so massive that it could completely encircle our own sun, capturing its vast energy directly. It's the kind of idea that sounds almost impossible, yet the possibility of such a monumental feat is what researchers are now considering. The idea of discovering an alien megastructure like a Dyson Sphere would be one of the most astonishing breakthroughs in the history of human science. A Dyson Sphere, a concept first proposed by British-American physicist Freeman Dyson in 1960, is a hypothetical structure that an advanced civilization might construct around its star in order to capture its entire energy output. To truly grasp the significance of this discovery, we need to dig deeper into what a Dyson Sphere is, the scientific context that led to its identification, and the monumental implications this could have for humanity and our future in space. What is a Dyson Sphere? Imagine a colossal system of satellites or energy harvesting panels orbiting a star, designed to collect its energy. This is the fundamental concept behind a Dyson Sphere. But the possibilities don't end there. Dyson Spheres can range from a loose configuration of individual energy-collecting satellites, known as a Dyson swarm, all the way to a fully enclosed shell that completely surrounds a star, capturing every ounce of its energy output. This concept represents the ultimate in energy exploitation, a level of technological achievement that only a Type II civilization on the Kardashev scale could ever hope to reach. By contrast, humanity is still hovering at Type 0 on this scale, as we have yet to fully harness even the energy resources of our own planet. If a Dyson Sphere were discovered, it would not only confirm the existence of intelligent extraterrestrial life but also indicate that this life has achieved technological feats that are far beyond anything we can currently imagine. This realization alone is staggering. But the methods used by scientists to identify potential Dyson Spheres are equally captivating, and they reveal just how advanced our search for extraterrestrial technology has become. How do we detect Dyson Spheres? The quest for Dyson Spheres began with the realization that such structures would likely leave behind specific, unusual signals in the light emitted by their stars. A Dyson Sphere would alter the stellar light spectrum in very distinct ways, producing irregular dimming, excess infrared radiation, and other anomalies that suggest artificial energy harvesting technology is at work. For decades, astronomers have used groundbreaking tools like the Kepler Space Telescope, the James Webb Space Telescope, and advanced ground-based observatories to look for these specific signatures. The data collected by these instruments has allowed scientists to meticulously scan thousands of stars for signs of these anomalies. The discovery of one star in particular, KIC 8,462,852, famously known as Tabby's star, has sparked global interest after its peculiar and erratic dimming patterns didn't match any known natural phenomenon. At first, scientists explored natural causes like the presence of a massive cloud of comets or dust clouds, but none of these explanations fully accounted for the strange patterns observed. Eventually, the possibility of a Dyson Sphere entered the discussion, as the data continued to define natural explanations. The role of artificial intelligence and machine learning in this discovery cannot be overstated. By analyzing enormous datasets from telescopes like Kepler, AI systems flagged subtle, complex patterns and anomalies that might have been missed by human eyes. One star stood out among the rest, Tabby's star, whose light curves displayed periodic dips in brightness, patterns that seemed to indicate something massive and artificial was moving in front of the star. Further analysis by the James Webb Space Telescope, with its unprecedented sensitivity to infrared radiation, revealed excess infrared emissions surrounding the star. This excess radiation strongly supported the theory that the star might be surrounded by a Dyson sphere or a similar energy-collecting megastructure. The profound implications of a Dyson sphere. The discovery of a Dyson sphere would not just be an astronomical finding, it would fundamentally change our understanding of the universe and humanity's place within it. It would raise enormous questions. Who built this massive structure? What type of civilization had the power and capability to create such a thing? What could we learn about the alien species that constructed it? The answers to these questions would likely lie in realms of science and technology we have yet to fully comprehend. For one, building a Dyson sphere would require monumental advances in materials science, energy management, and astrophysics. The materials needed to withstand the intense gravitational and thermal forces near a star are beyond anything we currently possess. We would also need energy storage and distribution systems capable of handling enormous amounts of energy, technology that we can only dream of at this point. But the implications of such a discovery go far beyond just technology. The very existence of a Dyson sphere would challenge our current assumptions about the rarity of intelligent life in the universe. It would suggest that advanced civilizations might be far more common than we previously believed, and that they may have developed ways of surviving and thriving in the cosmos that are beyond our wildest imaginations. This discovery forces us to reconsider what we think we know about the potential for technological progress. If an alien civilization has already achieved this level of sophistication, it serves as both a source of inspiration and a sobering reminder of how much farther we still have to go. The Fermi paradox revisited. This discovery also offers a fascinating potential answer to the Fermi paradox, the apparent contradiction between the high probability of extraterrestrial life, and the lack of evidence for it. Could it be that advanced civilizations aren't broadcasting radio signals or sending out visible signals like we once thought? Maybe they are focusing on colossal engineering projects like Dyson Spheres, projects that are far more difficult to detect. Alternatively, these civilizations may have decided to deliberately avoid contact with less advanced species, adhering to a kind of interstellar prime directive. This idea challenges our assumptions about how we might one day interact with other intelligent life forms. Ethical and philosophical questions. Of course, the discovery of a Dyson sphere would not just pose scientific challenges, it would also force us to grapple with a range of ethical and philosophical dilemmas. If these alien civilizations are still around, should humanity try to contact them? What would be the potential risks and benefits of reaching out to such a highly advanced civilization? On the one hand, establishing communication with these extraterrestrials could lead to an unparalleled cultural and technological exchange, opening up possibilities for knowledge, exploration, and collaboration. On the other hand, such contact might expose humanity to unknown dangers, including potential hostility or exploitation. Studying the Dyson Sphere. Studying the Dyson Sphere could have extraordinary implications for human knowledge. If we could understand how such a structure functions, we might learn new principles of energy management, material science, and even quantum physics. We could gain insights into advanced technologies that might accelerate our own technological progress. However, direct observation of a Dyson sphere is an incredibly complex challenge. The distances involved are so vast that studying it from Earth would require some of the most advanced instruments known to humankind. We might need to rely on techniques like interferometry, where data from multiple telescopes are combined to create ultra-high-resolution images. Alternatively, space probes might need to be deployed to gather closer, more direct observations. The future of humanity. Ultimately, the discovery of a Dyson sphere has far-reaching consequences for humanity's future. If we hope to one day build similar structures, or even achieve anything close to it, we will need to overcome massive challenges, such as resource scarcity, environmental degradation, and global inequalities. But studying these structures, and learning from civilizations that have built them, could provide us with the guidance we need to address these challenges and create a sustainable, prosperous future for ourselves. Questions about civilization and technology. As we continue to study this Dyson sphere, we must also reflect on the civilization that created it. What type of society would be capable of embarking on such an enormous and sustained effort? What kinds of cultural values, governance systems, and technological innovations would be necessary for such a civilization to succeed? Were they motivated by necessity, perhaps driven by a crisis in energy or dwindling planetary resources? Or was it the sheer ambition to push the boundaries of their technology and knowledge that led them to construct such a monumental structure? Understanding their motivations could offer valuable lessons for humanity as we face our own challenges. The possibility of contact. If the creators of the Dyson sphere are still out there, what would the future hold for us if we were to make contact? Could they see us as fellow explorers, eager to share knowledge, or would they view us as primitive beings unworthy of their attention? The risks of miscommunication or conflict are enormous, but the potential rewards, the chance to join an interstellar community, are just as great. In closing, the discovery of a Dyson sphere represents far more than just an incredible scientific achievement. It offers a profound opportunity to reflect on the nature of intelligent life in the universe and our place within it. The lessons we could learn from this discovery, both scientific and philosophical, have the potential to shape the future of humanity. As we stand on the threshold of this new era, let us approach it with curiosity, humility, and a deep sense of wonder. There is so much more to discover, and the universe is waiting for us.